Today we're going to be talking about rates of change in slope. Rates of change is a fancy way of saying slope. You should hopefully know this slope formula. Okay, rise up, run out. So y over x. So the slope is the change in y over the change in x. So you subtract the y coordinates, subtract the x coordinates. Okay, so that's honestly, you guys should really remember that from Algebra 1. So college admission, okay, in 2004, 56,878 students applied to UCLA. In 2006, they had 60,291. Find the rate of change in the number of college students applying for admission from 2006 to 2004 to 2006, and explain the meaning of the slope. Okay, so what that means. Okay, we really have 2 points there. We have 2004, and then the value, so that's time, our independent variable, dependent variable. And then we have the year again and the number of students, okay? Time is typically our independent variable. Year is dependent. The year depends, or the number of students applying depends on the year. Okay, so we take the y coordinates. I'm going to take the larger number, subtracting from the smaller number. Now, so I started with this y coordinate, so I have to start with 2006. Okay, so then I don't expect you guys to do that without a calculator. So doing that in my calculator, I get that value. And what does that mean? Okay, that means, I'm going to be fancy and type it out here. The number of applicants went up 5 students per year. Okay, so let's talk about how I got what I got. Okay, so the number of applicants, okay, you have to give me what I'm talking about. The number of applicants went up, telling me that our slope is positive. If it is a negative slope, you'd say something like decreases. Students per year. Let's look at this. Let's look at this fraction here. What's the value? What were these numbers standing for, I should say? That was students. Was on the top. On the bottom, what was the units there? Our units was years. Okay, so we had students per year. And that's what rate of change is, okay? So when I ask you guys to find the rate of change, that's all you're finding. Okay, find the slope of the line that passes through those points. Okay, so let's take -2 minus 4 all over, I started with -2, so I have to take 1 minus a -1, so I get -6 over 2, which is a -3. Not too bad. Okay, that's super basic. Okay, now finding the slope and y-intercept. Okay, so graphing these lines, now that I know how to find slope-intercept, y equals mx plus b. You guys should really know this. Okay, you guys, this should have been drilled in your brains. Okay, so to find the equation of this line, you need to solve for y. So I need to isolate y in this equation. I need to isolate this y. So I'm going to subtract the 4x over. Now what I need to do is I need to isolate the y, so I need to divide each and every term by a 7. So we get this. And leave the slope as a fraction. Okay, my y-intercept is 4. So I go up to 4, and now I count out my slope. So I can count down 4, 1, 2, 3, 4, and then to the right 7. I went down, which takes part of the negative, and then to the right 7. I can also go up 4 and left. Left tells me my negative part of my slope, 7. And when you're graphing things in slope-intercept form, I would like 3 points, and make sure I can tell that you have 3 points, and then connect with your ruler. And that's why we use a ruler, so that it goes through all 3 points. I was trying to freehand it. Point slope formula. Not a lot of math teachers, some math teachers like point slope formula, some don't. I like point slope formula because I use it a lot in calculus, and I want you guys to be exposed to it. Point slope formula. Okay, so that's the slope. M, always the slope. And then you have y1 and x1. Those are just coordinates of any point on the line. Where this formula came from is our slope. Slope y2 minus y1 over x2 minus x1. If I take and I multiply both sides by what's in the denominator to get rid of the denominator, we have y2 minus y1 equals m times x2 minus x1. Now, the equation of our line, we just talk about basic x and y values. So I can take away that square, that x2, that 2. So now, this is our equation of our line in point slope form, and that's where we got it from. We got it from our slope formula. Okay, write the equation of the line that has a slope of negative 3/5 that passes through that point. Remember, that's an x and a y. Okay, so what is my y value? My y value is negative 2. What is my slope? My slope is 5. I'm sorry, my slope is, I apologize, I'm not doing good today. My slope, I apologize, is 3/5. My x is 5 plus b. So when I multiply those together, the 5's cancel. And when I add the 3 over, we get a 1. So now plugging into y equals m x plus b, we get that equation right there. Now plugging in point slope form. Remember, this is x1, y1. Okay, and this is my m. So all you have to do is plug in. We have y minus y1, which is a negative 2, equals my m is negative 3/5, x minus x1 is 5. So from here, it's okay if you leave it like that. I'm okay with that. But I want to show you guys, to simplify this, you do get the same thing that we got over here. So I'm going to distribute the 3/5 through. Subtract the 2 over, and you see that we do get the same thing. Okay, using either form. Parallel and perpendicular lines. Parallel lines, same slope. That's what you need to take notes on. Parallel lines, same slope. Perpendicular lines, their product is negative 1. I think about it as they are opposite reciprocals. Okay? One slope is 3, the other one's negative 1/3. Okay, write the equation in slope-intercept form for a line that passes through 3, -2, and is perpendicular to the line with a slope of a -5. So my perpendicular slope is the opposite. If this one's negative, my new slope is a positive 1/5. And I have to go through the line. I have to go through the point -3, 2. Remember, this is an x, this is a y. My slope is 1/5. So 1/5 times 3 is equal to 3/5 plus b. When I subtract my 3/5 over, I get -13/5. Notice how I'm staying in fractions, and they're improper fractions. That's what I want from you guys. So now we have our equation of our line in slope-intercept form. Okay, so now when I want to write the equation of the line that's parallel, our slope is the same as what we have there, and we go through the point 3, -2, so y equals mx plus b. Y equals mx plus b. -2 is equal to a -15 plus b. Solving for b, we get a positive 13. So our equation, y equals -5x plus 13. So notice how obviously our lines parallel and perpendicular, not the same thing. Okay, there are your lesson questions for the day. Find the rate of change. Explain the meaning in a sentence. Finding our slope and finding the equation of the line. And make sure that you guys give me improper fractions for your answer. And please make sure that's submitted on time.